Hello everyone, our project is transition from IPv4 to IPv6. So now I am going to measure all the metrics such as latency, throughput, connection time, TCP connection time, and also TCP connections per second. So now I am doing this project in three mechanisms using the dual stack router. First of all, let us see the three mechanisms are IPv6 homogeneous network using IPv6 protocol, IPv6 application and IPv6 infrastructure. All these are used by IPv6 networks. So the other one is router to router tunneling, that is used IPv4 router. It is a heterogeneous network. So in here IPv6 application and IPv4 infrastructure is used both. So the other one is host to host encapsulation. Here you can see the IPv4 router and IPv6 application, and in host to host encapsulation IPv4 and IPv6 router. It is the dual stack router, and here the IPv6 application, the infrastructure is IPv4. So these are the comparison tests. So these measurements are all done with Wireshark application. So now let us see how the Wireshark can be used to do this throughput, TCP connection time, latency, etc. So now let us start the you can see these are the number of packets are receiving. First of all, let us see the first mechanism is the homogeneous network with IPv4. Now this is the system with IPv4 internet with the connection of IPv4 server from a client to web server. These are the packets receiving. Up to this we are receiving the 440 packets. Now here you can calculate it. Go to statistics and also let us see these are the TCP packets we are receiving. So this is the TCP packet. You can calculate the throughput, the round trip time. This is the latency. So now for the convenience we can put the cross on. This is the latency. First of all, the x-axis is number of connections, the time per seconds. So now latency is known as round trip time. It is the amount of time it takes one packet to travel from client to server and back to the originating host. This is performance measured in microseconds or seconds. Now we are measuring in seconds. Here you can see the sequence number is nothing but number of connections per. Here we got 15 connections per 0.2 seconds. This is about latency or round trip time graph for IPv4. So let us see the next one is throughput. Throughput for IPv4. Here we can see the maximum throughput. So throughput, the rate at which bulk data transfers can be transmitted from one host to another over a period of time. So here the x-axis we can see the time with seconds. The y-axis is bytes per second. Here approximately it is 90,000 bytes per second. Sorry, it is bytes, not bytes, it is bits. These are approximately 90,000 bits we are getting for IPv4. The another graph is time sequence. It is TCP connection time. You can see here for IPv4 the TCP connection. First of all, TCP connection is the metric measure, the amount of time it took to establish a TCP connection between the client and server. Between the client and server, it is the x-axis is times per second, y-axis is number of connections. We get approximately 1000 connections per second for IPv4. So now let us see the next mechanism is heterogeneous network for the IPv6 application. So we can here we see the IPv6 with the heterogeneous using the IPv4 router and IPv4 protocol. So for this, let us calculate the throughput, TCP and latency. So first of all, see the round trip time, that is nothing but latency. Here we can see the latency is increased with, but it's not increased, it is as similar to the IPv4. You can see the latency measurement in this graph. So that is the number of connections in the x-axis and the time in y-axis. So within a small time we have a increase in the connections, that is 1400 to 1500, in between it is approximately 1450 for 0.04. Then it is reliable and the number of connections increased than IPv4 connection. Now so the throughput for IPv6 is almost 86,000 per second, 86,000 bits per second. We are getting the highest. The IPv4 is 80,000 approximately, and this is 86,000 approximately. So now we can see here the a small change, that is nearly a 3% change, or of course 2% change we can see in the throughput of IPv4 and IPv6. Now the next one is TCP connection time. So here we got the x-axis is same as time per second, the number of connections is 207. So this is the time connection, the time sequence graph for the IPv6. So now we can see the dual stack router from the IPv6 host. It is the router with IPv4 and IPv6, the existing infrastructure IPv4. So this is the encapsulated packet with IPv6 over IPv4. So let us see the measurements in other different computer. So now for the dual stack host to host encapsulation, that is client to server, we can see the throughput. This is the throughput. The throughput for the dual stack IPv4 and IPv6 both. This system is encapsulated and with IPv6 over IPv4. Now we can see here the x-axis with the time per second and y-axis with bits per second. We can see the huge number of increased number of bits in this IPv4 and IPv6 dual stack router. For this we can say the throughput is high and it is reliable and it is better than IPv4, the dual stack. So now let us see the round trip time. So the latency, we can see the latency we measured here For this, the x-axis is the number of connections, the sequence number, and the time here is on the y-axis. For the 0.3 seconds, we got 5500 approx nearly, not nearly, it is approximately 5500 connections for the latency through IPv4 and IPv6 dual stack. So the other one is time connection, TCP connection. Here we got the TCP connection time. Here we can see it is nearly 9700 for the 69 seconds. We got a huge number increase in the TCP connections, and it is better than IPv4 and IPv6 when compared to the dual stack router. So these are the measurements. Now let us see the dual stack input output graph with the time with x-axis and number of packets the x-axis. So here we can see this is keeping packets or bytes. So here the y-axis is the bytes and the x-axis is the time per second. So for 0 seconds, for 20 seconds, the number of increasing. So this is the for the server application, the number of packets receiving for the server through internet. So to summarize, in this project we presented the performance evaluation of IPv6 and the two transition mechanisms, namely host-to-host encapsulation and rotor-to-rotor tunneling over a local area network using the Windows operating system. So here we summarize our major results presented in this work: the host-to-host encapsulation and the rotor-to-rotor tunneling. So coming to this, the rotor-to-rotor tunneling with IPv4 protocol has a very little overhead compared to the IPv6 protocol. So the host-to-host encapsulation transition mechanisms performed slightly better than the IPv4 and the homogeneous network with IPv6. So our future work will continue with our evaluation with more transition mechanisms. Perhaps it is empirically evaluate all the available transition mechanisms. So we all intend to investigate as the flow label and the end-to-end application with this. So the dual stack router with host-to-host encapsulation is slightly better than the IPv4 and the IPv6 homogeneous network. Thank you.